For security operations and CISO teams, generative AI introduces an immediate, high-severity data leakage threat. The standard response is to shut off access entirely, implementing strict firewall-level domain bans against platforms like ChatGPT, Claude, and Gemini. But blocking a domain on the corporate network does not eliminate the demand for the tool. Employees facing rigid deadlines often find another route to the technology. Banning these applications at the perimeter fails to stop enterprise adoption. Instead, it drives the behavior underground. This diagram outlines the reality of modern network bypass. When an employee encounters a firewall block on their workstation, they routinely bypass the restriction by disconnecting from corporate Wi-Fi, switching to a cellular hotspot, or transferring the data to a personal device. These lateral routes circumvent centralized perimeter monitoring systems. The data leaves the monitored environment before the firewall registers a request. This unmonitored usage of generative AI tools to process corporate data is defined as shadow AI. The moment data enters a shadow AI workflow, IT and security operations teams lose visibility. They cannot audit the prompts, track the responses, or verify what proprietary information is being ingested by public models. By attempting to secure the network through a firewall ban, organizations inadvertently force data into unsanctioned channels, increasing the probability of an unmonitored breach. This loss of visibility triggers immediate regulatory compliance violations. Processing customer data through personal LLM accounts contravenes the data handling requirements of both SOC 2 and the GDPR framework. The life cycle of a shadow AI transaction is straightforward. An employee copies proprietary code or client data from a secure corporate environment and pastes it directly into a consumer-tier LLM account that lacks enterprise data retention agreements. This dual-axis chart tracks the resulting risk vectors. Routing data through an unsanctioned consumer channel generates an exponentially higher volume of risk compared to the baseline security of an authorized enterprise-grade API connection. This specific inflection point is where internal security tools lose their line of sight, and corporate data enters a third-party server with no contractual protections. Because perimeter defense cannot contain modern user behavior, security architecture must shift away from the network edge and move directly to the data. This requires adopting a zero-trust data sanitization model, or ZTDS. ZTDS replaces the brittle network ban with localized data defense. Enterprise compliance in the LLM era relies on moving past the firewall block in favor of a 100% client-side sanitization layer that protects data before it moves in transit. The primary goal of zero-trust data sanitization is to legalize AI innovation. By providing a secure path for these tools, organizations allow their teams to operate efficiently while maintaining compliance. To achieve this, the architectural boundary shifts. Instead of a distant firewall, a 100% client-side boundary layer is installed directly on the endpoint, living locally on the user's machine. Raw user text containing PII is typed into the terminal and enters the localized Privacy Scrubber interceptor node. Inside, a local regex engine scans the input, identifying and isolating specific PII token strings, like names, social security numbers, or API keys. Before payload encryption occurs, the system replaces these identified PII tokens with safe, anonymized markers. Only then does the sanitized payload leave the endpoint boundary, traversing the network to reach the public LLM API. Because this redaction occurs locally, it ensures that identified proprietary data never leaves the machine in plain text, creating a deterministic filter between the user and the cloud. This localized sanitization satisfies SOC requirements for data privacy by ensuring confidential information is contained within the audited environment. It also fulfills GDPR requirements regarding the processing of PII by third-party subprocessors, as the external AI model never receives the actual protected personal data. This localized filtration successfully isolates the enterprise's proprietary risk entirely, all without degrading the advanced reasoning performance of the external LLM. Implementing this architecture allows legal, human resources teams, and engineering departments to safely utilize public LLMs. Client-side interception transforms LLM usage into a provably compliant enterprise workflow. Securing a single endpoint solves the individual problem, but enterprise environments also require cross-departmental collaboration. teams need to share custom regex rules and sanitized session contexts. Traditionally, organizations use centralized servers to store and distribute these configurations. However, consolidating custom security rules on a single server creates a central point of failure. The architectural objective of the Privacy Scrubber Teams tier is to eliminate that central server vulnerability. This presents a specific cryptographic challenge, achieving secure peer-to-peer sharing across a decentralized network environment where the transit layer is assumed to be hostile. To solve this, the system utilizes Argonon2ID, a memory hard key derivation function. Argonon2ID derives a complex, localized cryptographic key directly from a shared credential at the first endpoint, utilizing memory hardness to resist brute force attacks. Next, the system introduces the XChaCha20 Poly 1305 stream cipher for authenticated encryption of the transit payload. The Argon2ID-derived key feeds directly into the XChaCha 2020 Poly 1305 block, encrypting and authenticating the custom regex rules into a locked payload. This encrypted payload then transfers across the void to the receiving endpoint. Because the second node holds the matching credential, it locally derives the same key to decrypt the rules. This pairing of algorithms ensures that even if an attacker intercepts the network transit layer, they cannot use usable data from the payload. By handling derivation and encryption entirely on the endpoints, this serverless transport architecture maintains the integrity of the zero-trust perimeter. Serverless cryptography allows internal team collaboration to scale without expanding the enterprise attack surface. Pulling back to the macro level, replacing perimeter bands with client-side cryptography shifts the security burden from the network to the individual endpoint. This is the operational flow of an enterprise fully deployed on a ZTDS architecture. Defense sits directly on the endpoints, linked by encrypted peer-to-peer connections. Sanitized data payloads flow from individual workstations to external public LLM APIs, clear of proprietary risk. Unlike a static network-level firewall, this dynamic system moves directly with the user, ensuring security regardless of the connection source. Relying on AI bans creates unmanageable shadow AI risk by forcing innovation into unmonitored channels. Zero-trust data sanitization neutralizes that shadow risk locally, redacting sensitive information before it ever reaches the network edge. Simultaneously, Argon2ID and XChaCha20 Poly 1305 secure team collaboration without relying on vulnerable central servers. Adopting this framework integrates the security operations team into the innovation cycle, providing a compliant path for the workforce to use advanced tools. When employees are permitted to leverage these tools within a secure framework, operational efficiency increases across the organization. Empowering the workforce through secure, localized Gen AI access drives business growth while maintaining regulatory compliance.